We're gonna cover reflection in this section. This is a very important and fundamental concept throughout the whole chapter. I'm using mirror as an example because this is the simplest form of reflection we could see. So this arrow is the object, and I use dotted line to indicate the virtual image of this arrow. And we're talking about this mirror, and anything that goes perpendicular to the surface of the mirror is called a normal. And I picked the normal here because this is the point where it intersects the incident ray right here and the surface of the mirror. So by the laws of reflection, we have two things in mind. The first thing is the distance of object would be equals to distance of image. This is the distance of object. This is the distance of image. And the second thing is that the incident angle is always equals to the reflected angles. So we're looking at this angle and this angle. And this angle is measured from the incident ray and the normal. The same goes with the reflected ray and the normal that goes with the reflected angle. So from this example, we could see that we have light rays that goes from the head of the arrow and goes from the tail of the arrows. And both arrows eventually strikes through our eyes, right? It eventually strikes through our eyes. That indicates that our eyes are looking at the arrows at this thing right here. So this is the length of the arrow we see. This is the length of the arrow we see on the mirror, but this is actually the actual length of the arrow. So this is about reflection, and what I'm gonna talk about next is smooth surface versus rough surface. And smooth surface, like mirror, it reflects light in one direction, and it reflects all the lights in that direction. And rough surface, what this rough surface does is that it diffracts the light. So for example, we see a paper, right? We see a paper, something like this, and we see it, maybe I should draw better. We see a paper like this. And when we zoom in the paper closely, we actually see like the paper is not completely straight line. It's not completely straight line. There are some rough surfaces that probably not really as small as atoms, but something probably closer to dust that makes the paper not smooth enough. So this is probably when you zoom in the paper closer and closer, this is the surface you get. And when you shine parallel lights to it, it's gonna diffract in everywhere. And when one of the ray hits our eye, then we could see the object. And why do we see colors? So take leaf, the green color as an example. It absorbs color, and what color it doesn't absorb is the color we see. So for example, we see leaf as green. It's probably it absorbs red the most, which is the complement color of green. So that is the reason why we see the leaf as green. And the last thing I'm gonna talk about is that what if there's more than one mirror? What image could we see? How many image could we see? So as we could see here, I have two mirrors, one here and one here. And then this is me, just think I'm a point source that I'm trying to look at myself. So one possible way is I could look at here, along the normal, probably the normal is here. So I look at the mirror on the left side, and then this is the reflected ray, and it goes back. And the same thing goes with the right side. It goes here and goes here. So the image, probably there's one image here, image 1. There's an image here, image 2. And then there's also one image at the far end here. And how this image is formed is like, consider that I'm in the angle bisector of these two mirrors. And then when I look at the rays, it's gonna go here to here, it's gonna bounce to here, and it goes back to me. And by geometry, we know that the way it works is that it goes towards this point, that it bounces to this point and goes back to us. But the thing is that we're not a point source. We have size, so it's not really the thing that if we are a point, then we just look at this point. We're a point source, so that is why the reason why when we're placed at the angle bisector, we can see ourselves somewhere here, where we see half of us in this portion and half of us in this portion. And that concludes.